Okay.
So do we want to just skip straight to the quiz on that one?
Yeah, let's do that because we've already.
Sounds good to me.
Pull that up real fast. It's actually, I think it's because they updated. Whatever they updated, for some reason my computer's not liking it. So I'm going to have to call IT and see what I need to do on that, because this class is not possible without those.
Yeah,
no way.
Okay, 8. Have any of you guys taken the exam yet?
No, I'm going to take it today.
I took it. It wasn't too bad.
Oh, that's good. I wondered when she put her note about, like people asking what questions got wrong and stuff, like if it was brutal.
Oh, I didn't think it was at all.
How many questions was it?
It was 38.
Okay.
It took me about an hour.
Okay.
Oh,
that's not bad.
It took 4 hours. I was like freaking out about that. I was like, why do we have 4 hours to take this test?
Yeah.
That long?
Yeah, it was a long time. But no, it didn't take that long at all.
All right, so I'm on the Lesson 8 group meeting quiz right now.
Mine just pulled up. There it is. And of course, you need this. Oh, see, now here's the thing. So now it says you need the following data set, and it's that Crossroads purchase. But this one's saved as an XLSX. But for some reason, on the BYU sheet, it's all saved as a .sav. And that's the one I can't get open. So hopefully these will open for me now.
Oh,
and they did, yeah, and they did. So that's so crazy. It drives me nuts. I need to just save them now while I have them in the XLSX.
Okay.
Because on that BYU one, it all has mine. They're all saved as .sav, and it's like a random file thing that I can't figure out how to open. But good news, this one opens for me here. And the normal probability app opens, so that's great.
This is a 30 question. It's like 30 questions for this, so.
This Lesson 8 one is?
Yeah.
Oh my gosh. Okay.
But I think it should go pretty fast because a lot of it's a review, so.
Yeah. Okay, so I'll go with number 2 because it looks like it starts there. Okay, which of the following variables is or are categorical? The number of animals. Oh, this is off our page, I think. The number of animals in the local zoo, a randomly selected brand of toothpaste, or age in years. That's going to be the randomly selected brand because it's not numerical. Oh, that is or are. Sorry, I read that wrong. Oh, that is right, yeah. So sorry, B, a randomly selected brand of toothpaste.
Do you think it would be multiple because you can select multiple, and I think it might be the third one too because it's talking about the age of randomly selected vehicles or the age and years of randomly selected vehicles in a parking lot. Do you think it would be that one too?
That's true. It could be because age. I was thinking it was numerical. But I guess you're not. It's not a number of. It's a category of years.
I'm just thinking it would be 2 different ones because there's the option to do 2 different answers.
Right.
Yeah.
Yeah, I think so too.
Okay.
Yeah, it sounds like it could be either one too.
Yeah, that's the hard thing. I'm like, age is a number, and usually numbers are quantitative, but it's not a mathematical number. It's a category of years.
Yeah.
That's a tough one. Well, that one we'll see when we first submit it.
Yeah.
We'll know it's the wrong one if it's not.
I'm here for that. All right, I'll do number 3. The mean IQ test score in the United States is 100. 20 randomly selected statistics students took an IQ test, and the mean of their scores was 112. Which of the following of their statements is true? 100 is a parameter, 112 is a parameter, 100 is a statistic, and 112 is a statistic. So I want to say 100 is a statistic, and then the 112 is a parameter.
I got it vice versa. I got 100. Yeah. 100 is a parameter. 112 is a statistic.
Okay. Sounds good.
Yeah, the parameter is the biggest. Everyone. Okay, 4. Rotham City has 4 distinct neighborhoods. The property values are very similar within each neighborhood, but they vary considerably from neighborhood to neighborhood. One neighborhood has very low property values and another has extremely high property values. Property taxes are usually roughly proportional to the property values. What type of sample would we collect to gauge the residents' responses to a proposed increase in property taxes? Simple, random, systematic, cluster, stratified. I would probably say stratified is one where you just take some from each group, right?
That's, I guess, stratified on that
Yeah, I
one.
think stratified.
Yeah.
You get some from each neighborhood.
Okay, so question 5. Since this is what we've already done, I'm just going to give the answer, and then if we disagree, we can read through them.
Okay.
So 5, I got cluster.
Wait, we already did these?
Yeah, this is actually exactly what the review question quiz is, or that we did.
From lesson
8.
Oh, was there a review quiz?
Or it's what the preparation work was.
Oh, from this lesson? From
Yeah.
like, oh, okay.
I didn't write the answers down, so I don't have them all.
Oh, okay. Then I'll read it. Sorry, you guys. And it's off a number. That's the hardest thing because it's number 1 isn't number 1 and stuff. But okay, so when design experiments are conducted in a public school systems, researchers typically choose a particular district, randomly select teachers of, say, 4th grade districts, or sorry, not reading them. 4th grade students in the district. The experiment is then conducted using all the students in the selected classes. Which type of sampling scheme is implemented? And I said cluster.
Okay.
Sounds good to me.
All right. At a school fundraiser, the name of every person who attended was entered into a drawing. Can you guys hear me?
Yeah.
Yes.
Okay. At the end of the evening, 6 names were selected to receive 4 prizes. Which type of sampling scheme was implemented? Sorry. Oh, sorry. It would be systematic, wouldn't it?
I guess simple random but I don't know. It could be systematic. I was just thinking because it was everybody and it was just like the names in a hat.
Oh, I was thinking it was everything. It's just 6 names.
Oh, it could be.
So it's just, you're right. It's simple random. I was thinking it said every 6 names were selected, but it's just
6 like out of a hat type thing.
Okay, yeah, then it was simple random. All right.
Okay, 7. A special interest group is conducting a survey regarding wolves in Yellowstone National Park. To adequately gauge opinions on both sides of the political spectrum, the researchers took the list of registered Democrats and selected a simple random sample of 100 people. Then they took a list of registered Republicans and selected a simple random sample of 100 people. Which type of sampling scheme was implemented? That is stratified again, right?
Yeah, can you remember what stratified is again?
I was thinking it was more clustered.
Oh, that could be. Well, clustered, they're not taking every single person from each group.
That's true. You're right.
Stratified is where you put things into groups that are simple, that are related to each other, and you take a random sample from some of the groups.
Okay. I'm just pulling up everything right. Okay, yeah.
Oh, from each group. You take a sample from each group for stratified.
So then it makes me wonder, do you think number 6 was wrong, or let's see, the Rotham City one. Number 4 was wrong then, because would it be stratified as well? Because money with low property values, high property values.
I think we put stratified.
I know, but I'm saying, would that be wrong because it's everybody in those clusters, not random?
Do they take them all?
Or I guess, no, I guess certified could work because it's asking us what type we should use, not what
so
type was used.
yeah. Just take all 4 neighborhoods and take some from each neighborhood.
Yeah, perfect. Okay, so for 7, stratified, right?
Yeah.
So other 30 questions.
Oh,
Here we go. Now we got some math going at number 8.
So this is the one I have not done yet because I didn't get it open before. Let's see here. Next 3 questions. Mean amount spent.
Crossword puzzle.
So for mean amount spent, we needed to add all up and do an auto sum, right?
Yeah.
It says on the bottom. It says on the bottom too. 4.771.
It says the amount.
Yeah, on the bottom of the page, if you look at the average, it'll tell you the average. You guys see that?
I don't see that.
So if you highlight amounts, it'll at the very bottom, like you see at the very bottom of the page how it says in the bottom left it says ready.
No.
Oh yeah.
And then go over it says average.
And it was 4.78.
4.7.
Or 4.77. I mean.
Yeah. 4.771 because it's around 2 decimals. Calculate the standard deviation. Oh, this we need that the quantitative descriptive statistics, I think. That one Excel sheet.
And where's that one found? Do you know?
That one's in lesson 2. I just have it saved on my laptop, but
that's smart.
It's asking, what is it asking for? Okay, so the standard deviation is 1.912. Holly, we can put our Callie, my little sister's name is Callie, so I was just talking to her.
Oh, no.
What are you doing?
Okay. It's funny. I went my whole life with no one. I've never had anyone with the same name of me until I was an adult, and now I hear it everywhere.
Oh, it's so popular now. I hear it a lot.
It was the one nice thing in school is I knew when they announced it, they called my name. I didn't have to it wasn't like my sister's name was like Jessica and Summer, so there was always like 10 of them. And I was like, nope, there's only one me.
All right, you guys see for number 9, you did 1.912, right?
Yeah, that's what I put. I'm just trying to pull up that formula real fast out of that week 2. Okay, so let's see. Okay, start by creating a histogram of the amount spent in Crossroads purchases, then mark the following statements as true or false. I created a histogram representing the amount spent. So we're obviously going to mark that true.
Yes, I think that's correct.
Does everyone know how to make a histogram?
Yeah, it's just it pulls it up right here for you, right on this page.
On the Excel sheet?
Yeah.
How do you pull that up real fast? Sorry.
So are you on the quantitative descriptive statistics?
No, that's probably why.
Yeah, you want that one.
Got it. I'm going to write that down so I know to go back and get that one.
Yeah, you can go back and do it.
Statistics. Awesome.
All right, on to the information for number 9. It says, Jessica Meir and her research team measured the body temperatures of a sample of diving elephant seals. A thermistor was placed at a specific location on each seal to measure its body temperature. The body temperature of seals tends to decrease as they dive. The researchers estimated the typical body temperature of each seal at the time they initiate a dive and they call this the representative temperature of the seal. Thermistors were placed in hepatic sinus in 4 of the seals, and the seal's body temperature at the start of the dive was calculated to be what's listed below. So then it says to complete the following table to answer the next 4 questions.
Okay, so this one I actually did. So hopefully I did it right.
All right.
Let's see here. So what I was taking from it was, so the deviation from the mean is going to be x, which is that number in the first box, minus the mean. So we had to take those 4 numbers and calculate the mean out of it.
Okay.
And then, at least that's how I did it.
Oh, yeah, that sounds right.
So as long as my mean's right, it should be right.
Is your mean 38.075?
Yes, that's what I got.
Okay.
So for A, which is question 11, I've got negative 0.165 was my answer.
Yeah, that's what I got too.
Me too.
And then for 12, for the B, I got 0.681.
Okay, yeah, awesome. Same.
Yep.
So question 13 says, what quantity is equal to the sum of the numbers in the squared deviations column?
So I think it's the standard deviation. But
Yeah,
that's
I believe.
my guess.
Asking.
Is that what you guys got?
Well, so what is it?
So it's all these numbers. So deviation from the mean is the first box, but the second box is the squared deviations.
Yeah.
And I'm thinking, so what I think it is that's what if you add them all together, that's what the standard
Deviation.
rate would be.
Oh, okay, yeah, that makes sense because it wouldn't be the mean or the variance.
Right, because the mean was the second box. So
okay, yeah, that makes sense. Okay.
And then let's see, what is the standard? I got 1.5341. So I guess it would be 1.534.
And you did that by adding all those up?
That's a great question. Yes. Oh my God, yeah, because I took, which ones did I had to have added the square deviations together.
Okay.
Since we've decided that the addition of that is the standard deviation.
Oh yeah, that makes sense.
Yeah, so 14, so yeah, that one makes sense as long as we were right on the one above it.
Okay.
Yeah.
I guess we'll find out.
And then 15, I got false because it says
Yeah.
they can never be negative.
Yeah, standard deviation can be negative. All right. I can read this one. In the same study, the researchers placed thermistors in the 3 seals near their spinal cord and brain in the intradural vein. They placed thermistors in 6 other seals in their aorta, the largest artery in the body. Finally, they placed the thermistors in 4 other seals in their hepatic sinus. The results from this study are summarized in the table below. So which location resulted in the most consistent temperature measurements from one seal to the other? Wouldn't it be the extradural? Because the standard deviation is the smallest.
That's what I would think.
Oh, yeah, that makes sense.
Okay.
Took me a minute on that, but yeah, it makes sense. Okay, I can read the next one. The number of hours students spent studying for an exam were recorded. The data is represented by the box plot below. Use the box plot to answer the next 2 questions. What is the third quartile? It is about, what is that, 8-ish?
So I guess 7, but I'm not sure. So it's just where the box is, right? The lines from the 2 to the 12 doesn't matter, right?
I thought it did matter.
Yeah, so the median is, for the mean, whatever it is the big line in the middle of the box. This, like right at 6.
Line over.
The 6, right?
Yeah, and the first is the next line to the left, and then the third is to the right.
Yeah, so I would
It
just.
looks like it's
Oh,
right.
okay. That makes sense. And yeah, I was for some reason thinking it was all encompassed within the box there.
Now, like the start of the box is the second, first. Yeah, I don't know. Okay.
So the minimum would be 2. The first would be 4. The mean would be 6. The third would be 8.
And the max would be 12.
Be 12. Okay.
Yeah.
So then it asks what percentage of the data lies between 4 hours and 8 hours. So that's talking about the 66, 90 something.
95, 98.7 or something like that. 99.7. 65, or sorry,
68,
66, 95,
66.
99.7.
So that'd just be like one standard deviation, so it'd be the 66, right?
It's 68. So it's 68, 95,
68?
99, yeah.
Oh, yeah.
Okay, so it says if the answer is 68%, then input only 66, not 0.66. So it's 68, just 68.
Yeah.
That's a tricky thing to throw in there.
I know, right? I didn't read that.
Okay, an observation from a normally distributed population is considered unusual if it is more than 2 standard deviations away from the mean. There are several contaminants that can harm a city's water supply. Nitrate concentrations above 10 ppm are considered a health risk for infants less than 6 months of age. The city of Rexburg reports that the nitrate concentration of the city's drinking water supply is between 1.59 and 2.52 parts per million, and values outside of this range are unusual. We will assume that U minus 2, da 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 da. It is responsible, or reason is it? It is reasonable to assume that the measured nitrate concentration is normally distributed. So, question: estimate the mean of measured nitrate concentration in Rexburg's drinking water. So the average. So would that be the average of 2.52 plus 1.59 divided by 2?
No, I don't think that's mean. I don't know though.
How do you get the mean out of that?
I mean, that's the only thing I can really think of. It just doesn't really make sense because those aren't two, like, they're not too different. It's just in between 1.5.
Yeah, it's between those numbers, so it's not saying it is either of those numbers. Okay, so so the mean minus 2 times the standard deviation equals 1.59. So do we know the standard deviation? Then we can just solve for the mean. No, we don't know that either.
We don't know that.
Equals 1.59. It's got to be something to do with these two formulas they gave us, but I can't figure out what.
I feel like these formulas are from like lesson 9 and 10.
That's what I was just thinking. Is those are more recent than. But that's why I'm wondering if it's easier than what we're thinking.
Probably.
So if it says the city of Exeter reports the nitrate concentration is between 1.5 and 2.52, that's why I wondered if it was just the average of those two.
We could try it.
Let's see, because if we do the average of those two, it's 2.055. But does that affect? The problem is though, this affects the next question, which is to estimate the standard deviation. So if it's wrong, we get 2 wrong. Estimate the mean of the measured nitrate concentration. Well, darn.
I think I figured out this one. Second though.
What's the formula for the standard deviation again?
That the Z one
Um,
equals X bar minus U divided by alpha divided by square root of N.
that's not the standard deviation, though, is it? Because standard deviation is the alpha. What lesson did we talk about standard deviations?
Okay. So I think number 19 is 2.055.
So that's what I got. That's just the average of the two.
Yeah, because then if you take, because what it says is with the two formulas, the average is 2 times standard deviation. So the average U is the average minus 2 standard deviations equals the 1.5, and then the average plus 2 standard deviations is the 2.52, and so it's just right in the middle of
Those two numbers. Okay.
Yeah, that makes
Yeah,
sense.
so the average is just plus and minus those two numbers, and so it's just right in the middle of them.
So we need to estimate
Well,
the
plus
standard deviation of the measured nitrate concentration. So did we ever figure out what our formula is we want to use?
Yeah, what was the formula for that?
Let's see here.
Standard deviation.
Okay, well, it's not lesson 2.
I think it might be lesson 4. Or lesson 3.
See, lesson 3 is the quantitative one.
Oh, yeah. I think it's lesson 4. I just am looking for an equation and I can't find it.
Can it just be? I think it's 2.33.
How'd you get that?
No, 0.233. So I just took the mean. Just a second. So the mean is. So we figured out that what the mean is just because it's 2 standard deviations away. So you just take 1 standard deviation and you add that to the mean. No, you just take the difference of these numbers that are 2 standard deviations from the mean. You just divide that by 2, and then you get 1 standard deviation, and that's just the standard deviation. Does that make sense?
Yeah, I just know there's an equation, and so I wanted to.
Oh yeah,
So,
I don't know what the equation is.
In lesson 3, there's the length of deployment days at sea, where it has the diving elephant seals question. And it says using SPSS, create a histogram for the length of the data, find the missing value. And it's the summary statistics that it shows are the mean, the standard deviation, and the sample size. So I think we have to plug it into that thing. That one file that I cannot find for the life of me. Is it called quantitative something or other?
You mean the Excel sheet?
Yeah.
It's called quantitative descriptive statistics.
I can't even find that listed on my thing. This is crazy.
Yeah, so, hey, Jason, did you get the standard deviation as 0.6558?
No.
That's what it says on the, when I did it. So it said the mean was 2.055, and then the standard deviation is 0.6576.
That's probably right, because I just kind of...
Yeah.
So
Thinking about
0.658 is the answer we're going to
Yes.
go with. Okay, so I'm sure still looking at that. The next question asks, between the two measured nitrate concentrations, do approximately 68% of the data values lie?
So that's on standard deviation. 68 is still on standard deviation. So
Yes.
So would you just add the standard? Yeah, you just add the standard deviation to 1 point.
Yeah, just add and subtract it to get both the numbers. I think.
But that doesn't really. None of those are on here. Well, it's within one standard deviation, so wouldn't it just be 1.59 and 2.520?
This is a lot harder than anything on the actual test.
That's good to know.
The actual test was way easier than this.
Well, let's go with the 1.59 for right now, and we'll come back to it if we need to, if we get that one wrong.
Wouldn't that be 100% though? Because 100% of the measured nitrate concentrations would lie in between. I guess not, but that doesn't really make sense. 68 is
Well, we said our mean is 2.055 with a 0.658 deviation. So it can't be 2.055 because that's our mean.
Yeah, but it really, I don't think it can be 1.590 and 2.520 because that's the original, that's the 100% of what it would lie between. So that's why I'm wondering if it would be the 1.8 and 2.288.
I'll put a calculator out here. Well, wouldn't it just be like 2.055 and you add
That's what
one standard of deviation?
That's what I thought, but then it didn't give an answer. Like, any of those.
2.713. Well, I think it's the 1.357 and the 2.753 because those are the closest, and we rounded. So if we hadn't rounded to 3 places, I'm thinking that's where we would be at.
But that's less than. That's 1.3 is less than 1.5, which is why I'm confused because it would.
I think. How did you get that standard deviation of 0.658? Because
I plugged it in.
Because if you use the standard deviation of 0.233, if you add and subtract that to the mean, you get the exact numbers of D, 1.832 and 2.288.
Where'd you get 2.33?
I took the mean and I subtracted 2.25, the mean from 2.52, I mean, and so we know that's 2 standard deviations, so then I just divided that by 2, and so that's just 1 standard deviation.
So I guess, so for 19, you have 2.055.
Right? Yes.
And 20, are you at 0.658?
Well, I have that there, but I think it's 0.233.
233.
Okay, let's try that. That's just weird. So you subtracted 2.055 from 2.52?
Yeah, and so then you get 0.465. So that has to be 2 standard deviations because of the formula that it gives us. And so you just divide that by 2 and you get just 1 standard deviation.
Okay, let's try that and keep.
Does that make sense?
Yeah.
Yeah, let's keep rolling because I know Kate's going to run short here on time in a second. Okay, what is the probability that a randomly selected student will score above 542.3 on the GMAT? So this is going to be a formula. Did I do this one? No.
So let's see.
So is this going to be a z-score calculation?
I think so, yeah, because then you have to use the probability applet to do the shade in the above.
Yeah.
What was the z-score? It is. Okay, there we go. So z equals. What was the population mean?
I think it's going to be 500 minus 542.3. Because the normal distribution is 542.3.
And then over standard deviation is 110.4. What's the sample size?
I don't think it's that formula.
Oh, you don't?
No, because we don't have a number.
That's true.
So I think it's just 500 minus 542.3 divided by 120.54.
Okay. Is that what you're seeing, Jason?
Yeah, I think so.
So I got z equals negative 0.351. Is that what you got?
Yep. So then we plug that into the applet.
And I think we only highlight the far right, isn't that?
Highlight everything to the right.
Everything to the right?
Because it's since the z-score is negative, we would highlight everything to the right of the negative z-score.
Yeah, and it's asking the probability of somebody being over that score too, if you want everything above it.
So did you get 0.6372?
Yep.
Yes, so did I.
So 0.637.
Below 600.
So then what is the probability that a randomly selected student will score below 600 on the GMAT?
So we have to change our z-score then.
It asks for below, right?
Mm-hmm.
I got 0.684.
That's what I got.
Yeah, me too.
What is the probability that the randomly selected student will score 600 or above on the GMAT? So we just need to change our
The direction.
direction.
So that would just be above. That would just be the only one shaded to the right, correct?
Right. So I chose 0.316.
Yeah. And then find the GMAT score that corresponds to the 10th percentile.
Okay, so
Remember how to do that.
I'm trying to think. I think seems like we changed the probability, like the area.
Yeah, you just plug 0.10 into the P score, the P number, whatever it is, at the top of the probability output.
And the 10th percentile, is that going to be the farthest in the right and left? Just
I think
left?
it's just yeah, just the left, because to the right would be a higher number. The left would be like 10 percentile is like really bad.
But isn't 10th percentile, there's 10% or higher and 10% or lower?
Yeah, that's true. No, 10% are higher, or 90% are higher, and 10% are lower.
Yeah, yeah, I think the right line would be 90%, and then.
All right. So did you get then 0.09 or shoot? I got lots of 0.09999.
Yeah, that's what I got too.
Yeah.
So let's see. So does that just become 0.1 then? It doesn't seem right.
I think it would be 0. Yeah, I think it would be 0.1 or 0.01. No.
Wait, what z-score did you get?
Well, the z-score I got is the negative 1.282. Oh, I see what you're saying. Hang on. I changed it to the wrong thing. So did you get negative 1.282?
Yes. Yeah.
Okay, I see what you're saying. But it says the GMAT score. So do we need to plug it in then?
Yeah, plug it into the formula.
Is that the z-score formula?
Yeah.
Yeah.
So we would use the z-score, right? And then
Did you get 387.78 or 77? I mean.
Yeah, I'm still working.
so we're trying to find the x bar, right?
Yes.
The heck?
Wait, what did you get, Callie?
I got 387.768.
That's what I got too.
Yeah.
Oh, round to the nearest whole number, so it's 388.
So then we have to do the G-score that corresponds to the 90th percentile. So that's,
So now we switch to the right side, right?
yeah.
Yes,
So
positive 1.282 for.
I got 696.14. Or just 696.
Yeah, so 697.
Well,
Yeah.
would it be 696, or do you round up? Because
Round up to the nearest whole number.
it just says round, so wouldn't we round down?
No, it says round to the nearest whole number. On mine, anyway.
Yeah, mine says that.
Yeah, I think on the lesson on this one it says you have to round up no matter what. Even if it's like 1, 2, you round all the way up.
Okay. So find the first quartile of the distribution of GMAT scores.
Oh wait, so what was number 26? Sorry, I was distracted.
Oh, not 697.
697. Okay.
So the first quartile of the distribution of GMAT scores. So we know our first number is back up here. Okay, so the minimum's a 500. The maximum is.
The mean is 142.
Minus 542.3. And what was our deviation?
120.54.
So would it be 421? No, that's never mind. Sorry. Crazy sauce.
Is there an equation for that?
I think you have to make is it a histogram?
No, you have to make a box and whisker plot.
Or, yeah, a box plot, I mean.
Yeah, I can't remember how to do that.
Me neither.
Yeah, we have to the next question is the third, so we need both of them.
I agree. Let's see. What lesson is this?
That's what I'm trying to find.
Is it 4?
Must be. Right. Well, it's either 2 or 4 because 3 is all about the histograms. So our box is after histograms.
I think it was after. I don't see anything though.
Ugh.
I think it actually because it talks about percentiles and quartiles.
Standard deviation.
Yeah, it's less than 3.
I'm trying to look. I'm looking at the PowerPoint for that she created for it to see if it gives us. So quadrant 1, 25% of data is lower than quadrant 1, and 7% is higher than. Calculate. Here we go. Calculating quartiles. So arrange data in ascending order. Quadrant 1 is the median of the data to the left of the grand median. So is it going to be the average between 500 and 542.3, I assume?
Yeah, I think so.
So 521.15?
Yeah. So 522.
Oh, yeah, sorry. Whole number. See, and that's what I hate, because if in normal rounding, I would never go, I would leave it at 521.
Yeah, that's where I get a little bit confused.
But Jason, you saw it say that we had to go up?
I think that's only for
up in.
I think that was only for finding like the amount of just a second. Actually, you know what? That might be for this next one. So that's for like finding the sample size of how many people you need to sample for.
Oh, yeah, because there's no half people, maybe. Okay, so for this one, I'm going to leave it at 521, since that.
Yeah, I think that's probably
what
right.
everything is, my math is telling me it has to be.
So then what about that one? What about?
Yeah, so 26.
So the third is 600, but we're saying is our high.
I think, yeah.
Well, but it can't be because for example, question 26, our answer was 697. 600, the minimum it has to be admitted. They won't accept anyone with less than 600.
So they don't really give us a maximum.
But it should be the same difference between the median to the quadrant 1 as from median to quadrant 3, shouldn't it?
Yes.
So if we take our 542.3 and subtract.
How much are you working on it now?
I'm doing quadrant 3, number 28.
I got 571. Because if you're taking 600.
But I don't think 600's right.
Oh.
Because if you see our questions above it, we went above. 600 is just the minimum they have to meet to even get looked at.
That's true. That's not actually it.
So I think if we take our 521.15, which was the first quartile number, and we subtract 542.3, we get 21.5 difference. So 542.3 plus 21.5 would give us 563.8.
For 563.
But like I said, something seems off about this, because then the final minimum number wouldn't even make it to 600. Or the maximum number, sorry.
Well, that's just the third quartile. So then the max number would make it to.
Yeah, the maximum can still be whatever number. It doesn't have to be even close to the quartile.
Okay, so we want to try 564.
Yeah.
You might as well.
Say at this point, let's just see what we get here.
Yeah, that's so true.
Okay, consider a simple random sample of n equals 15 students taking the GMAT. What is the mean of the distribution of sample mean scores of all such samples? Okay, so I think.
Would it still be 553?
Yeah, just saying the mean, right?
Yeah, because it's just the mean. I'm pretty sure that's it, because I think they're just trying to trick us with the whole sample thing, but the distribution of sample means is always the same as the mean.
Yeah.
Okay.
I remember there being questions on that on the other quizzes.
So what is the standard deviation of the distribution of sample mean scores for all such samples? So does that mean we're going to have to find the z-score formula using that with the n? Standard deviation.
Should be the same standard deviation, 120.54, right?
Yeah.
That's the population deviation, standard deviation.
Yeah, that's what I think.
So we just leave, so it's still just 120.54?
Yeah.
What is the probability that the sample mean score for a simple random sample of n equals 15 students will be greater than 600? So this is when we input it into the z-score, right?
I think so, but with the n included?
Yeah. So would x bar
So it would be
600?
Yeah, so I think it's z equals 600 minus 542.3 divided by 120.54 divided by square root of 15.
Okay. Okay, I got 1.854 for the z-score.
That's what I got.
Yep.
And it's asking,
It's greater than.
so I got 0.032.
That's what I got.
Okay. So with that,
Got all of them?
yeah.
Oh my word. Trying to check.
What'd you get for 31?
31.
32.
Yeah.
What was it?
0.032.
Here.
I'm going through making sure I actually answered all of them and didn't leave any blank.
Okay, I can submit mine real quick to see what happens.
Okay. I'm just going back through.
Okay, I got a couple of them now.
Womp womp.
What'd we get?
Okay, we got number 2 partly wrong.
Okay, so the age must not be one of them.
Okay, so
Yeah, and it says that the number of animals in the zoo is one of them, which doesn't.
Oh, the number of animals in the zoo should have been marked?
Yeah, that's what it says here. Just kind of weird.
So it was A and B?
Yeah.
That's weird. Okay, I'll write that one down so that way when we're going back through you can change. Oh, well, I guess we have to read all of them to you anyway. So what else was wrong?
3 was wrong. Says 112 is a statistic.
Yeah, it should be 112 is statistics, 100 is a parameter.
Oh yeah, I just didn't mark 2 of them. That's why.
Oh no. Okay, so A and D is what should be marked?
Yes.
Okay.
Yeah, I didn't even pay attention to that. There's more than one to be marked. Okay, so 6, 7, right. Okay, the next one is 13. 13 is supposed to be none of these. Is correct.
Oh, really?
Tricky, tricky.
So did we get 14 wrong then?
Yes. 14 is supposed to be 0.715.
Oh, we were way off.
Well, I think that makes sense because I think you add up all the numbers in that second column, and I think you have to square root it then.
Oh, okay.
The square root. Let me check real quick.
If I'm right, then that would be the square. 1.543 would be.
So for 14, though, the answer is 0.715.
Yes.
No, it wouldn't be the square root.
Oh, I don't know what it is then.
Okay, so I'm going to mark that one to ask the TA for those two, 13 and 14.
Okay. The next is 18.
What is it?
Number 18 is supposed to be just 50.
50.
50?
Which I don't know how we. 50.
Well, it actually, if you think about it, it does make sense. The box is misleading because if you look for, you have 2 to 4 no box, 8 to 12 no box, but you have 4 to 8 is. So isn't that? So let's see. That's 4, 5, 6, 7, 8 is 5. 2, 3, 9, 10, 11, 12. Well, I still don't know 50 though.
I think it's data around.
Okay, so 18 was 50. Okay, I marked it, but I'll mark it again for the TA. Just help us with that one. Okay, what else?
Okay, 22 is 500.
Sorry, 22 what?
Number 22 is 0.500.
500. Wait.
Wait, it's 0.500?
Yeah.
Okay. What's one's next?
Next is 27. 27 should be 461.
Wait. That means 28 is probably wrong too.
Yeah, 28 should be 624.
Wait, babe. Okay.
Sorry, what was 27?
Which one?
What was 27 and 28?
Oh, 27 should be 461 and 28 624.
Okay. Which one's next?
Next is 30. 30 should be 31.123.
Makes sense because that one would have to be wrong since those other two ones were wrong.
Yeah.
And then I'm guessing 31's wrong.
No, 31's right.
Oh, there you go. And what about 32?
We didn't.
Oh, there's no 32. Sorry.
Okay.
Okay. Do you want me to read these to you first, or do you want me to submit and see if those are all right?
Either way is fine.
Okay. And Kate, if you want to stay on there, I'll submit, and that way if I get it wrong too, you'll know.
Okay, sounds good.
Okay, so that was right. So if you want to open up yours, James, I'll read them. Oh, actually? Okay, so it was wrong. So the number of animals in the local zoo on mine was wrong, and it actually we were supposed to have marked.
Is it just a randomly selected genetic paste?
Well, I have green checks on Yeah, it's just a randomly selected random toothpaste. Sorry. It's where the arrow is pointing.
Oh, okay, my bad. I must have read it wrong.
Yeah. That just makes me feel better because I was thinking, how on earth is the number of animals categorical? Okay, are you ready, James?
Yeah, I'm ready.
Okay, so 2 was B. 3 is A and D, both of them.
Okay.
4 is stratified. 5 is cluster. 6 is simple random. 7 is a stratified random. 8 is 4.771. 9 is 1.912. 10 is true. 11 is negative 0.165. 12 is 0.681. 13 is none of these. 14 is 0.715. 15 is false. 16 is extradural. Am I going too fast?
No, you're good.
Okay, good. 17 is 8. 18 is 50. 19 is 2.055. 20 is 0.233. 21 is D. 22 is 0.5. 23 is 0.684. 24 is 0.316. 25 is 388. 26 is 697. 27 is 461. 28 is 624. 29 is 542.3. 30 is 31.123.
Can you go back to compare 29 again?
29 is 542.3.
Okay.
30 is 31.123. And 31 is 0.032. Oh, that was a beast of a thing. I hope the exam's not like that.
I thought the exam was way easier than that.
Okay.
There wasn't any of that like quartile doing it. Nothing. It was way easier than that.
Mhm. Okay, Kate, so do you want to move on or what do you need to do?
I was going to go to the temple, but I'll just go later today.
Are you sure? All right, I'm going to stop this one and I'll start lesson 9.
Okay.